Hi everyone, welcome back to our CSAC Quadratics course. We are on solving a quadratic, right? So we're much more than halfway through. We only have a little bit to go again. In this session, we will learn how to solve a quadratic, right? The conditions under which we solve a quadratic, and then we will also learn how to identify the important points when we solve a quadratic, right? What do we do with those points? So to solve a quadratic, it have one main condition, right? So to solve a quadratic equation, right? To solve a quadratic equation, solve a quadratic equation, at least one of the sides, at least one side. Well, actually, not at least one side, right? One side of the equation must be zero. It must happen, must be zero. Now, there are two main reasons for this here, right? I will show you the less important of the two reasons right now, and then when we get to graphs, you will see why it is so important, right? But one side of the equation must be zero. So that is, to solve a quadratic, it must look like this here. Ax squared plus bx plus c must be equal to 0. So this is an important step because a lot of times people will make the mistake and they will start to solve a quadratic when it looks like this here. So can the following equation be solved immediately? Can the following equation, can the following equation, can the following equation be solved immediately? Be solved immediately, right? So let's go with 5x squared minus 3x plus 2. If I squared minus 3x is equal to 2. So if we watch this here, neither side of the quadratic equation is equal to 0. So what we have to do in this case, you have to transpose this 2. So this is technically add 2, 0 plus 2. So when you transpose it, you have to subtract 2 from both sides. So it becomes 5x squared minus 3x minus 2 is equal to 0. And I don't like to say bring across to the next side, right? Always the easier thing to see is not really the correct thing to see, right? So you subtract 2 from both sides to balance the equation, and this is what we end up with. Now, this is able to be solved. So you always have to make sure you have it in the same order we're talking about x, well, the squared term, then the term with whose power is 1, and then the term independent of the variable in that order, right? And then one side must be 0. It don't matter if it's the left or right hand side, but typically we work easier when it's the right hand side. But it can be the left side equal to 0 or the right hand side equal to 0. Good. So this is how we do it. Now, what is the principle that we use? All right, so the principle that we use is this. So if A and B are any two numbers, and A multiplied by B is equal to 0, right? So let me think about this properly, right? If A is some number, we don't know what it is, and B is some number, we don't know what it is, right? And A multiplied by B is equal to 0. What does that tell us about A and B? How do we end up with 0 when two numbers are multiplied? All right, so take a 5 seconds, all right, pause the video and take however long you want and think it through. How could a result of a product of multiplying be equal to 0, right? So if we think it through, it must be that at least one of these two numbers must be equal to 0. So what we say is that either A either A is equal to 0 or B is equal to 0. Right? So if any two things are multiplying and the result is 0, it means that either one of them or the other one must be equal to 0, and that's very important, right? It don't matter what it is. Once you have two items being multiplied, two numerical items being multiplied in maths, and the result is 0, either the first one must be 0 or the second one must be 0 to give the overall answer of 0. So let's jump straight into some examples now. All right, so let's say for example, we have p into, sorry, solve 1, p into p minus 2 is equal to 0. So let me think this through and see if we could use, oops, sorry, if it is we could use what it is we had there just now to help us out here. All right, so now p into p plus 2, p minus 2, sorry, you all learned about this before. This means p multiplied by p minus 2 is equal to 0. But in this and this is basically the same thing. P in this case is A and B is the entire contents of the second of the brackets, right? So what we see here is that these are two numerical terms, right? P is some number that we don't know, right? And this is just another number. So either A by B is equal to 0, either 1. So A by B must be equal to 0. So what this tells us is that either the first term is equal to 0 or the second term must be equal to 0. And this is the principle that we are going to be using to solve quadratics. Right, so this will give us that either p is 0 or when you transpose the minus 2, it means to add 2 to both sides, you will end up with p is equal to 2. Now, if you're unsure about the transposing, this is one of those pre-knowledge topics, right? Where you are supposed to know how to solve simple equations, right? And I would have mentioned that in the first session of this series. If you need assistance as to how I got this here, right, from p minus 2 to p is equal to 2, feel free to let me know in the comments, right? So let's go again. Let's say that we have x into 3x minus 4 is equal to 0. Right now, the first instinct for a lot of people here is that they want to expand out these brackets. Do rush to expand brackets. A lot of times people just rush to expand brackets and it causes some problems, right? So with this one here, again, this is x multiplied by 3x minus 4 is equal to 0. So this is some term multiplied by another term is 0. If two terms multiply and the result is 0, it means that either the first term is equal to 0 or the whole second term is equal to 0. And let me show you why that's true. So this is true here. This is what the question gave us, right? So if x is 0, 0 by anything is 0. If this whole bracket is equal to 0, the contents of this bracket is equal to 0. And that means x by 0 will also be equal to 0. So you know that that's true. So this will give us x is equal to 0, or when we transpose the 4, it becomes 3x. You add 4 to both sides. And now when you transpose the 3, this is 3 multiplied by x. So this will give us that x is equal to 4 divided by 3. Now, in add maths, if you're doing this to help you out in add maths, you can leave it as an improper fraction, right? Improper fraction is one where the numerator is larger than the denominator. But if it's maths, you really should reduce it to a mixed number. Yeah. But if you leave it like this, I don't foresee them deducting any marks anything from here, right? But that's it. So this is the principle that we are going to be using to solve a quadratic, and let me show you how. Let's see that we factorize a quadratic and we get this. Right, so we end up getting this when we factorize a quadratic. So how is this principle, this a by b 0 principle working here? And this is the same as when you have two brackets next to each other. And that means that you are multiplying the contents of the brackets. 3m plus 2 is equal to 0. So what this gives us, this is like a by b. So either the first term a is equal to 0 or b is equal to 0. So this is either 2m minus 1 is equal to 0 or 3m plus 2 is equal to 0, right? So either the contents of the first bracket is equal to 0 or the contents of the second bracket is 0. If when they multiply, the answer is 0, that's the only way for this to be true. Again, to solve this here, this is solving what we call simple linear equations. So that's something that you're supposed to know from before, right? And if you don't, just comment in the section and say, sir, can you help me out with this? That's fine, and I'll guide it to a video to help, right? So this is subtract 1. So when you transpose it, it becomes 0 plus 1, right? So this will give us that 2m is equal to 1, and this is 2 multiplied by m. So this will give us m is equal to a half when we transpose the 2. Or this here is 3m plus 2. So this will give us 3m is equal to, when you subtract 2 from both sides, you'll get minus 2. And then when you divide both sides by 3, you will end up with minus 2 over 3, or minus 2/3. And that's the two answers. So let's see how true that is. Let's say m is a half. So if I put a half in this bracket here, 2 by a half is 1. 1 minus 1 is 0. And 0 by anything is 0. If I take minus 2/3 and put it in here, 3 by minus 2/3, when you work that out, is negative 2. Negative 2 plus 2 is 0. And 0 by anything is 0. And that's how easy this is. Now, what does this have to do with solving a quadratic? So let's get our own quadratic down here. Now, I have enough time to do one. And in the next video, I will do some more examples like this. Let's say that we are asked to solve 2x squared plus um, 12, 11x is equal to 0. Good. So if you notice, when we have these two brackets here multiplying by each other equal to 0, and that's the important thing, it must be equal to 0, we could solve. So that's what we have to do. We need to break this up into two brackets, but you all remember how to do that, right? You are looking for two numbers when multiplied giving us a by c, which is 24, and when added, giving us 11. You go through it, your factors are 24. 1 and 24 can't add to give you 11. 2 and 12 can't add to give you 11. What about 3 and 8? 3 by 8 is 24, and 3 plus 8 is 11. So that's 3 and 8. Again, if it is you're not sure how I got that, feel free to go back to the previous session, and you will, previous two sessions actually, and you will see how we did this. Good? So now you get 2x squared. It don't matter which number you put first. You can put the 8 first or the 3 first. I'll stick with the 3. 2x plus 3x plus 8x plus 12. Now, in this case, you have equal to 0. So in every line, you put equal to 0 again. When we were just factorizing alone, it had no equal to 0. So don't magically bring equal to 0 unless it starts off with that. Good? Now, you have x in common with these first two terms. So 2x squared divided by x is 2x plus 3x divided by x is 3. What could divide both of them? 4. 8x divided by 4 is 2x. 12 divided by 4 is 3 is equal to 0. And now we factorize completely. So we could take out the common 2x plus 3. And what we are left with is the terms outside x plus 4 is equal to 0. Now this is where we could solve. In the last sets of questions, we couldn't solve because it was an expression, right? It had nothing equal to 0. But in this case, we have it equal to 0. So now what we have to do, either the first bracket is the contents of the first bracket is equal to 0. So either 2x plus 3 is equal to 0 or x plus 4 is equal to 0. And finally, what we'll end up with here is when we carry, well, not carry across, but when we transpose the 3, you have to subtract 3 from both sides. This will give us 2x is equal to 0 minus 3, which is minus 3. Right? 0 subtract 3. So this will give us x is equal to negative 3 over 2 or negative 1.5, or x is equal to 0 subtract 4, which is negative 4. Right? And again, if you take negative 4 and put it in here, 4 minus 4 is 0. 0 by anything is 0. So this is how we solve a quadratic. A nice, easy process with a nice, easy principle. So join me in the next session and we will see how to solve some more quadratics. Until then, take care and stay safe, everyone.